Hello friends, welcome back to this YouTube channel. Today we want to talk about indices, and indices is just a plural of index, and index notation is just a way of shortening product of numbers of equal factors or numbers that are the same. For example, instead of writing 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, let's say multiply by 2 again, that is into 6. You can rather choose to write 2 raised to the power 6. So this all about index notation. And in this aspect, this 6 here is the index, or you call it the exponent. That is the power. So in indices, it deals with study of numbers with their exponent or the powers. And to study these numbers, there are some of the rules that we must follow whenever numbers are raised to a power or an exponent. So that takes us to the laws of indices. And in the laws of indices, we shall be talking about the following. We have number one, the multiplication law. Remember, all these laws are not in a special order. With that, I mean that you can mention anyone at any number. So let's, for example, for A, we have A raised to the power m multiplied by A raised to the power n. This is same thing as saying, since they have the same base, which is AA, same thing as selecting one base, then you add the powers. That is what this law is talking about. For example, if we have, let's say, 5 raised to the power 3 multiplied by 5 raised to the power 2, let's say multiply by 5 raised to the power 5 again. This is the same thing as saying 5 raised to the power 3 plus 2 plus 5, which is the same thing as 5 raised to the power 10. And 5 raised to the power 10 is the same thing as 9, 7, 6, 5, 6, 2, 5. Again, another multiplication law is saying that if we have A raised to the power m multiplied by B raised to the power m, remember, in this aspect now, they are no longer of the same base, but the powers are the same. So it's something as multiplying A by B, then two of them raised to power 1m. Because even product power law says that if you have something like this, you can still open the bracket to go back to this form. Another law, which we'll consider as number 2 here, is the division law. So in this division law, let's assume you have a number, say A raised to the power m, and another number A raised to the power n. It means that the number at the numerator is the same with that at the denominator, but they have different powers. These numbers can be written as A raised to the power n divided by A raised to the power n, and I believe we all know this, which is also the same thing as A. In the multiplication law, you selected one of the two numbers, the same way we selected one of the two numbers here. In the multiplication law, you added the powers, but in the division law, you are going to subtract the powers. So it's going to be the one at the numerator minus the one at the denominator. For example, let's say we have 2 raised to the power 6 divided by 2 raised to the power 3. This is the same thing as saying 2 raised to the power 6 minus 3, which is the same thing as 2 raised to the power 3. Or on the contrary, you can say that 2 raised to the power 6 is something as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, that is into 6. 1, 2, 3, 4, 5, 6. Then they said it's divided by, okay, this one is 2 raised to the power 3. So it's going to be divided by 2 multiplied by 2 multiplied by 2. That is into 3. And this will take care of this. This will take care of this. This will take care of this. So you now see that what you have left is 2 into 3. That is something as 2 raised to the power 3. So instead of going this long approach, that is why we use this. So this is number 2 law, and we call it division law. Also, under division law, if we have, let's consider this to be number A. If we have A raised to power m all over B raised to power m, it means you have two numbers of different values, A and B, but they have the same power. This number can be written as A all over B raised to power m. The same thing we did at number B of the multiplication law. For example, let's assume we have 5 raised to power 2 all over 3 raised to power 2. This can be written as 5 all over 3, everything raised to power 2. So that is all about division law. Then the third law is what we consider as the power law. The power law is of the opinion that if you have a number, let's say A raised to power m, close the bracket, raised to power n, that is the power we're talking about, the power law. It's same thing as saying equal to A. If you open the bracket, the powers will multiply the power. That is what this law is talking about, that when you have a number raised to a power, that if you open the bracket, the exponent will multiply the one that is outside the bracket. Therefore, you are going to have m n. The next law that we're going to talk about is the product power law. And for example, let's assume we have A, B, C. All these numbers raised to power n. If you want to open the bracket, all the numbers inside the bracket will be raised to the power. B raised to power n and C raised to power n. So this is what product power law is talking about. Having seen these 4 laws, let's look at some other special cases of the laws of these indices. And in those special cases of the law, let's consider the first one as zero index law. So this zero index law is saying that if you have any number raised to power 0, the same thing as 1. This can be proven as, when you have a raised to power 0, it's same thing as saying a raised to power n divided by a raised to power n. Of course, we know that a raised to power n divided by a raised to power n is going to give us 1. Then, and this a raised to power n all over a raised to power n is the same thing as saying a raised to power n minus n, from what we discussed under division law. And a raised to power n minus 1 is same thing as a raised to power 0. So if a raised to power 0 is same thing as a raised to power n minus n, and we know that a raised to power n all over a raised to power n will cancel themselves and give you 1. That means a raised to power 0 is equal to 1. The second special case of this law is the negative index. This negative index is of the opinion that if you have a raised to power minus n, is the same thing as taking the reciprocal of this number raised to its exponent. For example, we have 1 all over, the reciprocal of a is 1 all over a, then raised to the positive power, which is n. In demonstration, we can use a raised to power 3 divided by a raised to power 5. This, you can see that a raised to power 3 is something as a multiplied by a multiplied by a all over a raised to power 5 is a into 5. 1, 2, 3, 4, then 5, which is equal to a can cancel a cancel a cancel a. We now have a raised to power 2 because we have only 2a remaining. So the numerator is 1 all over a raised to power 2 because a multiplied by a is the same thing as a raised to power 2. So you now see that you have this to be 1 all over a raised to power 2. And if you want to solve this without going through this long approach, you would have said a raised to power 3 divided by a raised to power 5 is the same thing as a raised to power 3 minus a raised to power 5, which is the same thing as a raised to power minus 2. So a raised to power minus 2 is the same thing as saying 1 all over a raised to power 2. That is all about the negative index. Then the third special case is called the root powers. The root power. The root power is saying that if we have a raised to power 1 all over n, that it's same thing as saying root of a to n times. Then the last but not the least is a fractional indices. So we have fractional indices. And this is talking about if you have a raised to power m all over n, it's same thing as saying the root of a to the n time, then everything raised to power m. Let's, for example, if we have 4 raised to power 1 all over 3, then it's same thing as saying the cubic root of 4. Then let's let's change this to let's change this to 4. So it's the cubic root of 4, everything raised to power 4. So if you have 5 raised to power 2 over 3, it's the same thing as saying the cubic root of 5, everything raised to power 2. In summary, it's just the root to the power of the denominator, then everything raised to the power of the numerator. That is what this law is talking about. Now, having gone through all these rules, there are some examples in indices that you'll be needing like about 2 or more of these laws combined together before you can solve the problem. So let's use this simple example to demonstrate the laws. If we have something like this, you can just write solution. We have 2a raised to power 3 multiplied by 3a raised to power 4. You can all agree with me that this is the same thing as saying 2 multiplied by a multiplied by a multiplied by a multiplied by 3 multiplied by a multiplied by a multiplied by a and multiplied by a. So we have 1, 2, 3, 4, 5, 6, 7 a's. So you can simply collect like times 6, 2 and 3 are the same, and 2 multiplied by 3 is 6. That is 6 multiplied by a. The a is 7, so it's a raised to power 7. That will give you 6a raised to power 7. Then the second example, let's say we have x raised to power 4, x raised to power minus 6. Now, we are going to apply what we learned under multiplication law to solve this problem. They have the same base, which is the same thing as x. So, since they have the same base, you are going to select one base and add up the powers. The first x have the power to be 4, and the second x have the power to be minus 6. 4 plus minus 6 is same thing as 4 minus 6, which will give you x raised to power minus 2. Now, for the sake of objective questions, the questions or the answers to the question in the objective questions may not come as x raised to power minus 2. But then, don't also forget that under negative index law, we said that this is something as saying 1 all over x raised to power 2. So in the case of OBJ questions, the answer may come in this form or in this other form. But whichever way they twist it, just know that the answers are the same thing. Now, example number 3. Assuming we have x all over y raised to power minus 3. This is same thing as saying 1 all over x all over y, everything raised to power 3. This is because, don't forget that you can say let x over y be equal to a. Therefore, this question can be written as a raised to power minus 3. And you know that a raised to power minus 3 is same thing as 1 all over a raised to power 3. So if you have this problem, you just convert it in this format. And having done this, you can go ahead to open the bracket. And the law says that when you're opening the bracket, the powers will multiply the powers. This is x raised to power 3, then all over y raised to power 3. Also, if you have something like this, you can actually say 1 all over x raised to power 3, then multiply by y raised to power 3, so that your answer will be equal to y raised to power 3 all over x raised to power 3. Also in OBJ, the answers may be in this format: y raised to power 3, x raised to power minus 3. Whichever way it is, just know that the answers are the same thing. Now let's look at another example. If we have this problem, we can go ahead to open the bracket. So in opening the bracket, you see that 4x raised to the power 5 is going to multiply 3x raised to the power minus 9. And 4 and 3 are like times. So you can multiply the 2 so that it will give you 12, because 4 multiplied by 3 is 12. Then multiply by x. Remember, since x is multiplying x, from what we know in the multiplication law, we also said that it's going to be 5 then plus this other exponent, and this other exponent is minus 9. So 5 plus minus 9 is something as 5 minus 9. Therefore, we're going to have 12x raised to power 5 minus 9 is minus 4. So the answer will either appear in this form, or it will be 12 all over x raised to power 4. To avoid this video being too lengthy, we're going to end it here. But if you enjoy watching this video, kindly subscribe to this channel so that when we solve more problems under indices, you will have easy access to it.